Imagine, you've just been paid $5,000 to design this highly anticipated corporate logo for a startup. You spend weeks on it, you draw a beautiful, intricate design.
Yeah, you feel pretty good about it at that point.
Exactly. You send the file over, the client absolutely loves it, and they decide to print it on a massive highway billboard to celebrate their launch.
Right, a huge win for you.
Until a week later, you drive past that billboard on your commute, and instead of your pristine design, you see like a blurry, jagged, pixelated staircase of colored blocks.
Yeah, man, the worst.
It looks like it was built in a retro video game, completely unreadable, and then your phone rings. It's the client, and you're fired.
It is honestly the ultimate designer's nightmare.
Yeah.
The real tragedy is it happens all the time to people who have incredible artistic vision, but they just lack the underlying structural knowledge of the software they're using. They build a house on a foundation of sand.
Right. And today we are talking about the invisible mathematical foundation that prevents that exact nightmare. We are moving away from the idea of the digital canvas as like a free-flowing, smudgy painting, and stepping into the world of architectural precision disguised as art.
Yeah, we're going to understand how to build visual assets that are utterly bulletproof.
Which is why I'm so incredibly excited about our source material today for this deep dive. We are breaking down the core design concepts for someone just starting their career.
Or even for that veteran who has been, hacking their way through software for years and finally wants to understand how the architecture actually works.
Exactly. We are specifically extracting the knowledge from Chapter 08 vector drawing techniques out of a truly foundational text. It's called Adobe Photoshop CC Classroom in a book 2018.
That text is a cornerstone for a reason. What it lays out in that specific chapter isn't just a list of software features.
No, not at all.
It is the fundamental logic system that governs the entire modern design industry, from web development to 3D rendering.
And before we get deep into the physics and math of it all, I want to make sure you, our listener, have this material at your fingertips. You can actually buy the book by scanning the QR code of the book link provided in the description below.
It really helps to follow along.
It does. Seriously, having the text in front of you while we discuss these mechanics is a game changer. Also, please make sure to follow for more technical design breakdowns and career-building content, because we are going to be dissecting these industry-standard workflows regularly.
We definitely have a lot of ground to cover today.
We really do. So let's start with the root cause of that billboard disaster we talked about. Before you even touch a stylus or a mouse, you have to understand the literal fabric of the digital environment you're working in.
Right, because when you open a file, you are immediately forced to choose your reality. Are you working with a grid of fixed data points, or are you working with pure geometry?
That is the great divide in digital graphics. You are choosing between a bitmap image and a vector graphic.
And if you don't understand what is happening under the hood when you make that choice, you cannot reliably produce professional work.
So let's unpack the bitmap side first, which the text also refers to as raster graphics. When we take a photo with our smartphones, we are generating a bitmap. The software is laying out a rigid, invisible grid.
Yeah, and it is filling every tiny square in that grid with a specific solitary color value.
And it does that because the real world is incredibly nuanced, right? If you take a picture of a forest canopy, you are capturing millions of microscopic variations in light, shadow, and color temperature.
Exactly. A grid of pixels, where each dot can be a slightly different shade of green, is just the most efficient way to capture continuous tone imagery.
But the critical limitation, and this is what destroys that billboard, is that a bitmap contains a strictly finite amount of information. It has a fixed resolution.
Precisely. The computer is remarkably literal. If you have a photograph that is 2,000 pixels wide, the computer only possesses 2,000 specific data points of information across that horizontal axis.
Okay, so it has exactly that many dots and no more.
Right, so if you command the software to make that image 10,000 pixels wide for a billboard, the computer doesn't magically generate new detail. It doesn't know what was actually in the forest.
It just takes the existing data points and forces them to take up more physical space. So if I'm picturing this, a bitmap is essentially a beautiful, incredibly complex mosaic tile floor. From a distance, all those tiny colored tiles blend together to create a stunning, continuous picture of a forest.
That's a great way to look at it.
But if I try to stretch that mosaic to cover the floor of an airplane hangar, the tiles themselves don't multiply. The gaps between the tiles just stretch, the tiles become massive blocks, and suddenly my delicate forest looks like a jagged, chunky mess.
That's a perfect visualization. The technical term is interpolation, where the software tries to guess what colors should go in the newly created gaps, but it always results in that blurry, soft, or jagged edge.
And that jaggedness is the death of brand identity.
It really is. A corporate logo, a sleek app icon, crisp typography. These things cannot have soft, guessing edges. They require absolute, razor-sharp precision at any scale.
Which brings us to the other side of the divide, vector graphics. The text defines these as being constructed from lines and curves defined by mathematical objects. So we are completely abandoning the mosaic tile floor here.
You're abandoning the grid entirely. You are no longer painting dots. You are plotting coordinates on a Cartesian plane.
Okay, geometry time.
Right. You are telling the software point A exists at this exact mathematical coordinate, and point B exists at this coordinate, and the line connecting them follows this specific algebraic equation.
So to stick with the floor analogy, if the bitmap is the physical tile floor, the vector is the architectural blueprint for the room. It's the mathematical recipe.
Exactly.
If the blueprint says, draw a perfect circle in the center of the room, it doesn't matter if I scale that blueprint to fit a dollhouse or the Taj Mahal. The mathematical ratio of a perfect circle remains absolute.
Because the computer just recalculates the math on the fly, rendering it with infinite crispness.
That's wild.
And that concept of parametric design, where things are defined by parameters and equations rather than fixed data, is the bedrock of modern engineering. When you create a vector graphic, you're writing code.
Really? Like actual code?
Yeah. In fact, if you take a vector file like an SVG, which is a scalable vector graphic, and open it in a text editor, you won't see an image. You will literally see lines of markup language and mathematical coordinates.
That is fascinating. So when I'm drawing a logo in a vector program, I'm effectively generating HTML-style code visually.
Exactly. And that is why web developers love vectors, because the file size is minuscule compared to a photograph. A photograph has to store the color data for 10 million individual pixels.
Whereas a vector just stores a few lines of algebraic equation.
Right. It loads instantly on a website, and whether the user is viewing it on a tiny smartwatch screen or a massive 4K Retina monitor, the browser simply runs the math and renders it perfectly sharp.
So the hallmark of a professional is knowing exactly when to deploy which reality. Photographs, complex shading, digital painting that requires the mosaic tiles of a bitmap.
But logos, typography, iconography, laser cutting templates, those demand the mathematical perfection of vectors.
And what makes modern software so incredibly robust, and what this specific chapter highlights so well, is that an application like Photoshop is no longer just a photo editor.
It's a hybrid engine.
Yeah, it can process a massive continuous tone raster photograph in the background and seamlessly calculate crisp, infinitely scalable vector math right on top of it in the exact same document.
Okay, so if we accept that vectors are the goal for our logos and clean designs, the obvious question becomes, how do we actually write this math without typing out algebraic equations in a text editor?
We need a tool that translates our visual intent into geometry.
And that introduces us to the most notorious, revered, and misunderstood instrument in the entire digital design arsenal, the pen tool.
Oh man. It really is notorious. The pen tool is the one thing that stops aspiring designers dead in their tracks. It is wildly counterintuitive.
It really is.
Because despite its name, you don't pick it up and draw with it like a pen on paper.
No, if you try to use it like a traditional pen, you will end up with a chaotic, unmanageable mess.
Yeah.
Before we analyze how you manipulate it, we need to understand what it actually generates.
Okay.
The pen tool doesn't create pixels. It doesn't lay down ink. It creates something called a path.
The text makes a very clear distinction here. A path is essentially an invisible wireframe. It's the skeletal structure.
Yes.
If you just grab the pen tool and draw a complex path on your screen, and then you send that file to your printer, a totally blank piece of paper will come out. The path has no physical presence.
It is pure potential. It is a geometric boundary. If you want that boundary to become visible to the human eye, you have to apply properties to it.
Like giving it color.
Right. You have to tell the software to fill the inside of that mathematical boundary with a color, or to stroke the outside perimeter of the boundary with a specific thickness. Once you apply those visual properties, that invisible path becomes a vector shape.
So how do we build this invisible skeleton? The text explains that the pen tool relies on plotting anchor points.
Yeah, think of them as the joints in the skeleton.
Right. So if I want a straight line, I don't drag my mouse across the screen. I click once to drop an anchor point, let's say coordinate x1, y1. Then I move my mouse to the other side of the screen and click again to drop a second anchor point at x2, y2.
And the software instantaneously calculates the shortest distance between those 2 points and draws a perfectly straight vector line connecting them.
Straight lines are the easy part. The mathematical complexity and, well, the source of everyone's frustration comes when you need to introduce curvature.
And this is where I need you to break down the mechanics, because this is where the brain just misfires. To draw a curve, the book instructs us to click to drop an anchor point. But instead of letting go of the mouse button, we hold it down and drag the cursor away from the point.
Yeah, and when you do that, these little antennas shoot out from the anchor point. The text calls them direction lines that end in direction points.
To understand what those direction lines are doing, we have to look at the history of how this math was developed. These were actually called Bézier curves, named after Pierre Bézier.
Oh, who is that?
He was a French engineer who worked for the Renault car company in the 1960s.
Wait, the tool I used to draw logos in Photoshop was invented to design cars.
Yes. Before Bézier, if a car company wanted to design the aerodynamic curve of a fender, they had to build physical clay models. Bézier needed a way to describe complex, sweeping aerodynamic curves to early computer-controlled milling machines. He needed a mathematical system that was intuitive enough for a designer to manipulate without needing a PhD in calculus. So he popularized a system based on parametric equations and tangents.
Okay, so how do these direction lines represent a tangent?
Think of the direction lines as gravitational pulls. Or better yet, think of it like a dog on a leash.
A dog on a leash.
Yeah, the anchor point you placed is the owner, standing completely still on the grass. The direction line is the leash. And the direction point at the end of the leash is the dog, straining to pull forward.
Okay, I'm picturing it.
Now, the vector path itself is the trail the dog leaves in the grass as it runs from the first owner to a second owner across the yard. The longer you drag out that direction line, the longer you make the leash, the further out the dog can swing in a wide sweeping arc before it has to eventually curve back in to reach the second anchor point.
Oh, I see.
The angle of the leash dictates the trajectory of the curve, and the length of the leash dictates the momentum or the weight of the curve.
That completely changes how I visualize it. I'm not drawing the curve itself. I'm setting the parameters of the physics. I'm defining the tension and the angle, and the software is doing the calculus to render the smooth line that results from those forces.
Exactly. You are controlling the tangent vectors. And this is why the text stresses the difference between two types of anchor points, smooth points, and corner points.
Right, because if I have a smooth aerodynamic car fender, I want continuous curves. The text says a smooth point links the direction lines on either side of the anchor point like a seesaw.
Yep.
If I adjust the trajectory of the curve coming into the point, it automatically adjusts the trajectory of the curve going out of the point in perfect tandem.
It forces mathematical continuity. It guarantees that there are no abrupt, jagged transitions in the curvature. But design isn't only about smooth aerodynamics.
Yeah.
Sometimes you need a sharp, aggressive change in direction.
Like the tip of a crescent moon or the sharp point of a star. You can't have a seesaw effect there because the curve coming in doesn't dictate the line going out.
Which is where you deploy a corner point.
Yeah.
By utilizing a keyboard modifier, usually the Alt or Option key, you can grab just one side of that seesaw and break the connection.
You just snap it.
Exactly. You snap the direction line so it moves independently.
Yeah.
Now, the curve coming into the anchor point can be a wide, sweeping arc, and the line exiting the anchor point can instantly shoot off as a perfectly straight line in a totally different direction.
Okay, I understand the mechanics, and the history with Winnow is fascinating, but I still have to push back here.
Sure.
The text explicitly mentions that Photoshop has a freeform pen tool, a tool that literally lets you drag your mouse and draw just like a pencil, and it automatically drops the anchor points for you. If the software is smart enough to do the math on the fly based on my hand movement, why are we forcing beginners to suffer through this mechanical, dog-on-a-leash manual click-and-drag system?
Because the software is actually too literal. When you use the freeform pen tool, it is tracking every microscopic tremor in your hand, every tiny fluctuation in the polling rate of your mouse.
Oh.
To map that organic movement, the software panics and drops dozens, sometimes hundreds, of anchor points in a frantic attempt to capture your exact trajectory.
So a curve that I could draw manually with 2 points ends up having 50 points. Why does that matter if it looks okay on the screen?
Because of the golden rule of vector graphics, which the text highlights as a core principle. The fewer points you use, the smoother the curves are and the more efficient your file is. Remember Pierre Bezier and the milling machines?
Yeah.
If you send a vector path with 50 cluttered microscopic anchor points to a CNC router to cut out a wooden sign, the physical drill bit is going to stutter and vibrate wildly as it tries to calculate a new mathematical tangent every millimeter.
Oh, wow.
The cut will be rough, jagged, and terrible.
Yeah.
If you use a manual pen tool and define that exact same curve with just 2 anchor points and a beautifully stretched direction line, the drill bit glides in one smooth, continuous, elegant motion.
Wow, so mastering the manual pen tool isn't just about being a purist. It is about file optimization, mechanical translation, and pure structural elegance. You are trying to find the absolute minimum amount of mathematical data required to express a shape.
It is digital minimalism. The amateurs have 100 points. The masters have 3. Oh, and here's a quick pro tip from Adobe evangelist Julianne Cost mentioned in the text.
Oh, let's hear it.
Press P for the pen tool and use Shift plus P to quickly cycle through the nested pen tools. It saves so much time once you get the hang of it.
That's a great shortcut. So we've laid down a massive amount of theory. We understand the difference between pixels and math, and we understand how Bezier curves manipulate geometry. But as any professional knows, theory is useless until you apply it to a practical pipeline.
Absolutely.
The deep dive now shifts into applying this knowledge to the core exercise of Chapter 08, which is the Kailua Coffee Project.
This is where we take the abstract calculus and turn it into a tangible commercial asset. The text provides a scenario. We have a high-resolution bitmap photograph of a red ceramic coffee mug sitting on a table with an ocean background.
Okay, setting the scene.
And the client wants a logo for a shop called Kailua Coffee. And they want the logo to be the exact shape of that specific mug.
So we have to extract the geometry out of the photograph, we have to look at the raster pixels, analyze where the edges are, and manually build a vector path around it.
It's essentially reverse engineering the physical object into a mathematical blueprint.
The book walks through the tracing process, and it puts the concepts we just discussed to the test right away. You start at the top edge of the cup. For the long vertical side of the ceramic mug, the book instructs us to hold the Shift key while clicking our second anchor point at the bottom of the cup.
And that's a crucial workflow habit. When you constrain an action with the Shift key, you are removing human error. You don't have to guess if your hand moved a pixel to the left or right.
Oh, because it locks it.
Right, the software mathematically locks the line to be perfectly plumb, either exactly 90 degrees vertical, strictly horizontal, or a perfect 45-degree angle.
So we drop a perfect straight line down the side, then we reach the rounded bottom of the mug. Now we can't use a straight line. We have to click, hold, and drag to pull out our direction lines, utilizing that seesaw smooth point to create a gentle arc that traces the curve of the ceramic base.
You are matching the tension of your vector leash to the physical curvature of the photographed object.
Right. We curve around the bottom, we draw another straight line up the opposite side, and then we hit the critical juncture, the handle. The ceramic handle doesn't blend smoothly into the side of the cup, it juts out abruptly.
Which is the perfect real-world application of the corner point. If you tried to use a smooth point there, your vector path would create a soft, bubbly transition, which isn't physically accurate to the object.
So, following the text, we drop our anchor point where the handle meets the cup. We drag slightly to establish the initial curve of the handle, but before we drop the next point, we hold down that Alt or Option modifier key, and we click right back on the anchor point we just made.
And that instantly snaps one half of the direction line, breaking the seesaw.
You've severed the mathematical dependency.
Exactly.
Yeah.
And now your very next click can shoot straight out along the top edge of the handle without warping the side of the cup. It takes an incredible amount of mental focus at first: click, drag, alt-click, move. But I imagine once you do this for a living, it becomes complete muscle memory.
It becomes a rhythm. You stop seeing the photograph and you just see the geometry waiting to be traced.
So we trace all the way around the exterior of the mug over the handle, and we click back on our very first anchor point to close the path. We have a completed, continuous vector outline of the cup. But we have a major architectural flaw.
The negative space.
The negative space. We only trace the exterior silhouette, which means the area inside the loop of the handle, the hole where your fingers would go, is currently solid.
So if we filled this path with black ink right now, it wouldn't look like a coffee cup.
No, it would look like a solid black cylinder with a weird solid black tumor on the side. We need the inside of that handle to be completely transparent so the background can show through.
And this introduces a concept that extends far beyond Photoshop. To solve this, we have to look at path operations. We need to understand how multiple mathematical shapes interact when they overlap.
The book instructs us to keep our main solid cut path active. Then we look up at the tool options bar, and we change a setting from combine shapes to subtract front shape. The cursor actually changes, adding a little minus sign to the pen icon.
That tiny minus sign represents a massive conceptual leap.
It really does, because with that minus sign active, we move into the center of the handle loop, and we draw a second, smaller path tracing the inside curve. And the moment we close that second path, a hole punches perfectly through the solid shape of the cup.
The background photo instantly reveals itself through the gap.
If I can ask, how do you visualize what just happened there? Because a lot of people think they just used an eraser tool.
That's the trap. You did not erase anything. I always visualize this using a becking analogy. The first large path we drew, the solid silhouette of a cup, is a giant sheet of rolled out cookie dough. The second, smaller path we just drew inside the handle isn't an eraser, it is a cookie cutter.
That's a great way to look at it.
By selecting Subtract Front Shape, we told the software to press that cookie cutter down into the dough and remove whatever geometry fell inside that boundary. We didn't delete pixels, we changed the mathematical rules of the overall shape.
Changing the mathematical rules is exactly the right phrasing. What the text is teaching you here, under the guise of tracing a coffee cup, is Boolean logic.
Wait, Boolean logic? That sounds incredibly intimidating.
It really shouldn't be, but I get why it sounds that way. It is literally the foundation of digital computation.
Okay, but how does that apply to drawing a coffee cup?
Well, it's named after George Boole, a 19th century mathematician. He wrote a book called The Laws of Thought because he wanted to reduce complex human logic into simple algebraic equations.
Yeah.
True or false?
Yeah.
Yes or no, 1 or 0.
Okay.
Boole developed operations based on set theory. If you have two sets of data, or in our case, two geometric shapes,
Yeah.
how do they interact? You can have a union, where the two shapes merge into one giant shape.
Makes sense.
You can have an intersection, where only the overlapping area remains. Or you can have a difference, where one shape subtracts its exact volume from the other.
Ah, so Subtract Front Shape is a Boolean difference operation.
Precisely. And grasping Boolean operations in this 2D environment is a massive career milestone, because this logic scales up to every advanced design discipline.
Like 3D modeling.
Exactly. If you ever transition into 3D modeling using CAD software to design physical products, you don't build a car engine block by carving it like clay. You create a solid cube of geometry, you create cylindrical vectors, and you use Boolean difference operations to punch perfectly mathematical cylinders out of the cube to create the piston chambers.
That is mind-blowing. The exact same cookie cutter logic I used to cut a hole in a 2D coffee cup handle is what an industrial designer uses to bore holes through a 3D engine block.
It is a universal language of digital architecture.
Okay, so we've successfully traced the mug, we've executed a flawless Boolean subtraction to hollow out the handle, and we have a perfect scalable vector path of a coffee cup. It was painstaking work. And as a professional, if I spend an hour perfectly plotting Bezier curves, I refuse to ever trace that specific cup again.
And you shouldn't have to. Efficiency is the defining metric of a profitable design agency. You cannot afford to recreate assets from scratch. This brings us to the necessity of future-proofing your work, which is the core focus of the next phase of the project.
We need to save the geometry. The text guides us through a process that feels deceptively simple. We select our perfectly crafted path, we navigate up to the Edit menu, and we select Define Custom Shape.
Right.
A dialog box pops up, we name it Kailua Cup, we hit OK, and the path just seemingly vanishes from our active workspace.
It hasn't vanished. It has been absorbed into the software's permanent architecture.
Right. It's now living inside the custom shape picker, sitting right next to the default shapes the software ships with, like the perfect circles, stars, and speech bubbles.
Think about the power of what just happened. You took a custom, organic shape derived from a real-world photograph, translated it into pure mathematics, and packaged it into a proprietary tool. You essentially programmed a new feature into Photoshop.
And the implication of that is massive. 6 months from now, if a totally different client wants a cafe menu, I don't need to hunt down the old project file. I don't need to retrace anything.
No, you just pull it up.
I open a completely blank document, grab the custom shape tool, select my Kailua cup, and simply click and drag. I can drag it out to be 2 inches wide for a business card or 200 feet wide for a blimp, and the software will instantly generate a mathematically flawless, razor-sharp coffee cup instantly.
It's the ultimate return on investment for the time you spent mastering the pen tool. To finalize the visual of the logo in the exercise, the text actually leverages this exact workflow. We drag out our new custom cup shape and we fill it with solid black ink.
Okay.
Then we access a pre-existing custom shape that comes with the software, a lightning bolt.
And we apply our Boolean logic again.
Exactly. We select the lightning bolt, set its path operation to subtract front shape, and drag it right over the center of our black coffee cup.
So our lightning bolt cookie cutter punches a jagged hole right through the center of the solid black cup, allowing the beautiful blue sky from the background photograph to shine through the silhouette. It instantly transforms a basic mug outline into a modern, edgy, energetic brand mark.
But a visual mark is only half of a brand identity. The other half is typography, the text on the sign. And here, the book introduces a workflow concept that separates isolated hobbyists from collaborative professionals.
It introduces importing external assets. The text provides a file named logotype.eeps, which contains the words Kailua Coffee in a specific stylized font. Now, what really jumped out at me is that this text wasn't created in Photoshop.
No, it was created in Adobe Illustrator.
And that file extension, EPS, I feel like that's a term designers hear thrown around constantly without really knowing what it is.
EPS stands for Encapsulated Postscript. To understand why it's the industry standard, you have to go back to the origin of Adobe itself. John Warnock and Charles Geschke founded Adobe in the 1980s specifically to invent PostScript.
What was PostScript?
It was a revolution in printing. Before PostScript, computers and printers didn't speak the same language. A computer would try to send a block of pixels to a printer, and the printer would just guess how to output it, usually resulting in a blurry mess.
That sounds chaotic.
It was. PostScript was a universal programming language that translated digital geometry into physical printer commands. An EPS file encapsulated PostScript is basically a secure, self-contained envelope holding that perfect mathematical code. It guarantees that an intricate vector design built in Illustrator will maintain its absolute mathematical integrity when you drop it into a completely different software environment, like Photoshop.
So we need to get this EPS file onto our coffee shop sign. The text instructs us to go to File and choose Place Linked. We navigate to the EPS file and it drops the text onto our canvas. It looks incredibly crisp. But in the Layers panel, it doesn't look like a normal raster layer, and it doesn't look like our custom shape layers. It has a specific little chain link icon on the thumbnail.
That icon indicates it is a Link Smart object, and this is arguably the most critical technical concept in modern design workflows.
Okay, I have to play the skeptic here. Because to a beginner, this feels like an unnecessary layer of file management. Why bother linking to an external Illustrator file?
What do you mean?
Why not just open Illustrator, highlight the text, copy it, and paste it directly into Photoshop as a bunch of pixels and be done with it? It seems so much faster than worrying about where an EPS file is stored on your hard drive.
What you just described, copy and pasting as static pixels, is known as destructive editing. And in a professional environment, destructive editing is financial suicide.
Financial suicide? Walk me through that.
Imagine you are the lead designer at an agency, and you're running a campaign for Kailua Coffee. You've built this beautiful Photoshop mock-up of the main outdoor sign. You copied and pasted the logo as pixels.
Okay, done.
Now, because the campaign is huge, you also design a 50-page menu layout, a massive website hero banner, 10 different social media templates, and employee uniform mock-ups, all in different Photoshop files, all featuring that pixel-posted logo.
Okay, the campaign is fully built out.
The client reviews the campaign on a Friday afternoon. They say, "We love it," but the CEO just decided the font and the logo is too aggressive. We need you to change the K in Kailua to be slightly softer. Have it ready for Monday. If you use destructive editing, you now have to open the master Illustrator file, fix the K, and save it. Then you have to open the Photoshop sign mockup, delete the old pixel logo, copy the new one, paste it, resize it, try to perfectly match the position, and reapply any lighting effects.
For every single file.
Then you have to open the 50-page menu and do it again, then the website banner, then the 10 social templates, then the uniforms. It will take you the entire weekend, and you will inevitably make a placement error on one of them, destroying the brand consistency.
That sounds miserable. So how does a Link Smart object solve this?
A Link Smart object is non-destructive. When you use Place Linked, Photoshop doesn't absorb the pixels. It basically creates a live open window looking directly at the external EPS file on your hard drive. It renders what it sees through that window.
So the date isn't actually in Photoshop?
No. So Friday afternoon, the client asks for the font change. With a Link Smart object workflow, you simply open the original Illustrator EPS file. You soften the K, you hit save, and you go home.
Wait, what about the 50 other files?
The moment you open the Photoshop sign mockup, or the menu, or the website file, Photoshop looks through that live window, sees that the external EPS file has changed, and it instantaneously updates the logo across every single document automatically.
That's incredible.
It retains all your scaling, all your positioning, and all your visual effects. A weekend of tedious, error-prone manual labor is reduced to a single save command.
That is the difference between a freelancer drowning in revisions and an agency running a profitable, scalable pipeline. The text notes that you can also have embedded smart objects where the data lives entirely inside the Photoshop file without needing the external file on your drive.
Embedded objects protect you from losing quality if you scale the asset up and down, which is great. But you lose that miraculous cross-document synchronization. If you're building a brand campaign, linking is mandatory.
All right, so our architectural foundation is solid. We have our scalable custom vector shapes. We have our non-destructive linked smart object typography. The mechanics are flawless. But visually right now, our sign looks incredibly flat.
Very flat.
We have solid black shapes sitting on top of a 2D photograph. If this is supposed to be a physical sign outside a cafe, we need to integrate these elements into the physical reality of the scene.
We need to simulate depth, texture, and light. But we face a technical paradox. Our elements are mathematical vectors. If we want to add shadows and highlights, we can't just grab a digital paintbrush and start painting black and white pixels onto our logos.
Right, because the moment we introduce pixel paint to a vector shape, we rasterize it, we turn it back into a mosaic tile floor, and we lose all of our infinite scalability and crisp edges. We would destroy the foundation we just spent an hour building.
Exactly. So we have to apply aesthetics mathematically. We use layer styles.
The text walks us through applying these styles to the imported Illustrator logo type first. Instead of painting, we access the layer styles engine. First, we apply a color overlay to change the text from its original black to a deep, rich burgundy.
And notice the philosophy there. We didn't change the color of the original EPS file. The EPS is still black. We are telling Photoshop to mathematically project a red filter over the vector shape specifically within this document. It's entirely non-destructive. You can toggle the red filter off with a single click at any time.
The real magic happens with the next style. We activate, bevel, and emboss. Now, instead of describing what buttons to click, help me visualize what the software is actually doing when I turn this on. Because instantly, the flat red text looks like it's made of thick, carved plastic. It has bright highlights catching the sun on the top edges and dark, heavy shadows underneath.
It's doing basic ray tracing calculation. When you activate bevel and emboss, you are essentially establishing a localized 3D environment for that specific 2D shape. You tell the software, imagine a theoretical light source shining from the top left corner of the document at a 120-degree angle.
Okay, a virtual sun.
Yes. The software then analyzes the vector path of your text. It calculates where the boundary of the shape exists, and it mathematically extrudes a virtual edge. Then it runs a real-time lighting calculation.
Like actual physics.
Pretty much. It determines which edges of your vector path are facing the virtual sun. And it applies a screen blending highlight to those pixels and which edges are turned away from the sun. And it applies a multiply blending shadow.
It's calculating simulated physics. That is brilliant. So we have this beautifully lit 3D looking text, but we also have our flat coffee cup logo sitting beneath it. We need them to match perfectly. They need to look like they were carved from the same material and lit by the same sun.
And trying to manually recreate that exact same lighting angle, shadow depth, and exact hex code of burgundy red from scratch would be incredibly tedious and prone to inconsistency.
Which is why the text reveals an incredibly satisfying efficiency trick. You do not have to rebuild the math. In the Layers panel, you can simply hold down the Alt or Option key, click on the little effects icon indicating the layer styles on the text layer, and literally drag it down and drop it directly onto the coffee cup layer.
It copies the entire stack of mathematical parameters. Instantly, the cup is perfectly burgundy, perfectly bubbled, and perfectly lit from the exact same 120-degree angle. Consistency is achieved in a fraction of a second.
It is so satisfying to execute. Now, up until this point, we have been working in isolation. Everything is happening locally on our own hard drive. But there is a phenomenal extra credit section at the end of this chapter that forces us to look beyond our own computer screen. It introduces creative cloud libraries or CC libraries.
This is a vital evolution in how the industry operates. Historically, designers were siloed. You had your assets on your drive, I had mine on mine. If we collaborated, we constantly emailed files back and forth, leading to version control nightmares. The CC Libraries panel moves the asset pipeline into the cloud.
The book instructs us to open this libraries panel and create a new, dedicated library called Kailua Kofi. Then we take our finished assets, the intricate coffee cup logo we traced, the styled logo type, and we literally just drag them from our canvas directly into this cloud panel.
By doing that, you elevate those assets from local files to universal cloud elements. The moment they drop into that panel, they sync to Adobe servers.
Meaning they're everywhere.
Exactly. You can close Photoshop on your desktop, drive to a coffee shop, open Illustrator on your laptop, and that exact same custom coffee cup shape is sitting right there in the panel, ready to be dragged onto a new canvas.
But the text takes it a step further than just shapes. It instructs us to grab the eyedropper tool, click on the vibrant red of the physical ceramic mug in the background photo to sample that exact pixel color, and then click a button to add that specific color to the CC library. We do the same thing for the bright blue of the ocean sky.
Let's talk about the psychology of why you would do that. Why save a color to the cloud?
Okay, let's hear it.
Imagine that 5-person agency again. You are the art director. You have 4 junior designers building out different parts of the Kailua Coffee campaign.
Right.
If you don't have a shared library, you tell the team, make sure to use the brand red. Junior designer A eyeballs the red and uses a slightly desaturated maroon. Junior designer B uses a bright cherry red. When all those marketing materials are printed and placed next to each other at the cafe opening, the brand looks fractured, cheap, and wildly unprofessional.
Total chaos.
But if you, the art director, sample the exact brand red, save it to a shared CC library, and invite your team to that library, you enforce absolute technical consistency. When junior designer A needs red, they don't guess. They click the official red swatch in the shared cloud panel. The software automatically applies the mathematically perfect hex code.
You are removing the human margin for error.
You're building a centralized source of truth for the entire brand. Mastering CC libraries isn't just a neat software trick. It is what makes a designer capable of handling enterprise-level clients.
And what blew my mind, showing just how expansive this ecosystem has become, is that the text mentions the Adobe Capture CC mobile app. It connects the physical world to this digital cloud architecture.
How so?
You can have this app on your smartphone. Let's say you're walking down the street and you see a mural with an incredible color palette. You pull out your phone, snap a picture of the mural, and the app algorithms extract a perfect 5-color theme from the image.
Oh, wow.
Or you see a cool vintage street sign with a unique shape. You took a photo, and the app uses edge detection to instantly trace it and convert it into a vector path on your phone. And because you are logged into your account, the moment you get back to your office and sit down at your desktop, those colors and that vector shape have already synced to your CC library. They're waiting for you in Photoshop.
It completely blurs the boundary between the physical environment and your digital workspace. You aren't just designing when you sit at a desk. You are constantly capturing, digitizing, and cataloging the architecture of the real world around you.
It is so incredibly cool. All right, to bring this specific Kailua coffee sign to the finish line, the text introduces one final layout technique utilizing smart guides. We want to take our new, beautifully styled 3D coffee cup logo and duplicate it to create a repeating decorative border along the entire bottom edge of the sign.
This brings us back to the Alt or Option modifier key. If you select the cup with the Move tool, hold Alt and drag it, the software peels off a perfect clone of the object.
Now, in the old days, keeping a row of multiple objects perfectly aligned horizontally and ensuring the exact same amount of distance existed between each one was a nightmare of pulling out manual ruler grids, doing division on a calculator, and nudging things pixel by pixel.
It was tedious manual labor.
But the text shows how smart guides eliminate the math. When you have smart guides enabled, as soon as you start dragging that duplicated cup, bright magenta lines dynamically shoot across the screen. They automatically lock onto the horizontal center of the original cup, snapping your duplicate onto an invisible axis so it can't drift up or down.
It's a parametric alignment system.
And it gets better. It dynamically calculates spatial relationships. The text says we drag the first duplicate out and scale it down. Then we drag a second duplicate. When we drag that second duplicate until it is exactly 4.5 inches away from the first one, Photoshop pops up a little numerical badge right on the canvas confirming the distance.
And here is the real magic.
Yes. When you drag out the third duplicate, the software's engine recognizes the pattern you are attempting to establish. As you drag the third cup closer, the moment it hits that exact 4.5-inch distance from the second cup, it magnetically snaps into place. And magenta arrows appear bridging all three cups, proving that the distance is mathematically identical across the board.
You don't have to calculate anything, you just follow the magenta snap.
You repeat that until you have 4 equally spaced logos marching perfectly across the bottom. The math is flawless, the layout is balanced, and just like that, the complex composite sign is completely finished.
And it is a sign built on an unbreakable foundation.
Okay, let's pull all of this together. Let's do a conceptual review, but instead of just running down a list of textbook definitions, let's apply everything we just analyzed to a hypothetical scenario. You get a call tomorrow. A massive logistics company wants you to design the logo that will be painted on the side of 10,000 cargo ships. It has to be crisp, it has to be perfect, and they want it to incorporate a custom shape based on an anchor. Walk me through the architecture of how you execute that based on Chapter 08.
First, I have to choose my reality. I am not opening a raster canvas. I am not painting pixels because a cargo ship requires infinite scalability. I'm working strictly in vector graphics, building a mathematical blueprint using coordinate data.
Excellent. The great divide is crossed. Now, how do you extract the geometry of the anchor?
I find a reference photo of an anchor, but I don't use the freeform pen tool. I need absolute CNC level precision. I use the manual pen tool. I use the shift key to lock in perfectly plumb vertical lines for the shaft. I click, hold, and drag to extend direction lines, creating seesaw smooth points to perfectly trace the aerodynamic curves of the anchor's flukes.
Smooth and continuous.
Right. And when I hit the sharp pointed tip of the anchor, I use the Alter option modifier to snap the direction line, creating a corner point that abruptly changes direction. I'm building the geometry with the absolute minimum number of anchor points possible.
The path is flawlessly smooth, but the ring at the top of the anchor is solid. You need a hole for the chain.
I execute a Boolean difference operation. I select subtract front shape. I draw a perfectly circular path inside the ring, and the software recalculates the equation, slicing a mathematical hole right through the geometry.
The anchor is perfect, but the client wants to use it on their website, their letterhead, and their employee uniforms.
I refuse to redraw it. I select the completed path, go to Edit, and define it as a custom shape. It is now permanently embedded in my software's architecture, ready to be deployed instantly at any scale.
They also provide their corporate typography as an external Illustrator file.
I do not destructively copy and paste the pixels. I use place-linked to bring that EPS file in as a linked smart object. If they ever rebrand their font, I update the master Illustrator file once, and it automatically propagates perfectly across the ships, the letterhead, and the website mockups.
You've just built an indestructible enterprise-level design pipeline.
It really is empowering when you understand how the software actually thinks.
And I think that leads to a really profound final thought. When you dedicate the time to truly master these foundational mechanics, when you understand Bezier curves, parametric editing, and Boolean logic, something fundamental shifts in how you perceive the world.
You stop seeing the world as a flat, continuous photograph.
Explain that. What do you see instead?
You start seeing the hidden architectural scaffolding behind visual reality. When you look at a sleek sports car driving down the street, you don't just see a shiny object. You mentally reverse engineer the Bezier curves that define the fender. You can visualize the tension of the direction lines the industrial designer used.
That's a huge shift.
Yeah. When you look at an intricate wrought iron gate, you see the Boolean subtractions that carved out the negative space. You begin to recognize the mathematical parameters governing the shapes around you. You transition from being a passive consumer of aesthetics to an active architect of form.
That is an incredible perspective. You stop laying mosaic tiles and you start writing the blueprint for the universe.
Exactly.
Well, if you are listening to this and you want to become the architect of your own designs, you have to build this foundation. I cannot recommend this text highly enough. It bridges the gap between hacking your way through software and truly engineering professional assets.
It really does.
As a reminder, you can buy Adobe Photoshop CC Classroom in a book 2018 by scanning the QR code of the book link provided in the description below. Get the book, open up Chapter 08, and start plotting those anchor points yourself.
It is the only way the theory becomes muscle memory.
And please, make sure to follow for more technical design breakdowns and career-building content. We are going to keep unpacking these complex industry pipelines for you. Thank you for joining us on this deep dive into the math of design. See you next time.